Hello everyone, in today's video we are going to be talking about the properties of matter. Okay, so what are some properties? We can classify them into two categories. We classify them into physical properties and chemical properties. And while we will dive deeper into chemical properties later, we're really just going to focus on physical properties for this video. So here's a list of some things that we classify as physical properties. So color, smell, size, density, melting point, boiling point, and state, as in if it's a solid, liquid, or gas. We can identify with any object all of these different things. So you can see in the picture there's lots of different colors, lots of different sizes. I know we can't smell it because it's a picture, but there would presumably be a lot of different smells. If we wanted to, we could measure the density, which we'll get into later. Different materials have different melting and boiling points, and there's definitely some different states of matter. They're not all just solid. Some of those little bottles have some liquids in them. So in order to describe matter, you can use any of these features, and this is not the only list. There are more properties than these, but these are the popular ones, common ones, and just the ones that I want to talk about specifically in this video that you can use to describe matter. Okay. So I think we need to at least show you what some of the chemical properties are. Again, we're not going to do a deep dive into these, but different matter has different chemical properties. So different things have different levels of flammability. So for instance, a piece of paper is much more flammable. If you put it next to some kind of fire, it's going to light immediately, right? While a piece of metal is not highly flammable. Okay? Reactivity, that's how likely your substance is to react in a chemical fashion, to actually go through a chemical reaction if it comes into contact with something. And oxidation is similar, but it's specifically the likelihood that something will react with oxygen. So that's where rust happens, is iron reacting with oxygen. Okay, so size, color, density, I think those are pretty self-explanatory. So let's talk a little bit about density. Density is how closely packed the particles are. So think styrofoam versus a brick, right? Styrofoam, if you pick it up, you can pick up huge portions of it, and it's very, very light. That's because all the particles are very far apart from each other. And the particles themselves are lighter, versus a brick. Pick up one brick, and the amount of styrofoam you would need to be equal to the mass of a brick is huge, right? That's because that brick is very dense. It also has particles that are likely larger than the styrofoam particles. Okay, but for now, you can just think of density about how closely packed the particles are. So that picture on the left would represent styrofoam. The picture on the right would represent a brick. Melting and boiling points. So these actually are, I think, pretty self-explanatory, but they're the temperatures that a material boils or melts at, okay? Or melts or boils at. And it's actually the same for a substance. For instance, water, we know melts. Water melts. Ice melts at 0 degrees Celsius or 32 degrees Fahrenheit. That's when the snow starts to go away, right? You're not going to randomly find snow at 75 degrees outside, right? Because it's too hot. Water will always freeze at 32 degrees and melt at 32 degrees if there's increasing or decreasing energy, depending. Okay? And boiling, you always get the same boiling point. I know sometimes it doesn't feel like it if you're cooking. But if you're boiling water, it always has to reach that same temperature, 212 degrees Fahrenheit or 100 degrees Celsius in order to actually boil. And you can actually use this as a method to identify or confirm the identity of some materials. Now, that's not something you'd probably do until like college, but that is something that you can do. They are consistent, and not everything has the same melting or boiling point. Okay, and state of matter. I want to dive a little bit deeper into these and how you identify them. Now, most of the time, it's pretty straightforward. You have an object in front of you. You're like, oh, yeah, that's a solid, easy. But some things are not so clear. So we're going to give some guidelines in order to identify. So a solid has a definite shape. If I have my cup right here, it's a cup. It's going to stay a cup unless we do something to it. It's not going to randomly transform into a book, right? It has a definite volume. So if I measure the volume of it today and I measure the volume of it tomorrow, it's going to be the same. That volume isn't changing. Definite mass, same thing. If I measure the mass today, measure the mass tomorrow, it's going to be the same. It has the same number of particles in it as it did before, so the mass is going to be the same. And it tends to be the most dense, okay? Is most of the time the most dense. Now there are exceptions to this. One exception is water. I know it's such a thing that's so around us all the time. It feels weird that water is an exception to anything. But actually, ice is less dense than water is, than liquid water. And there's a lot that happens because of it. It's why your ice floats. We'll talk more about that when we get into density. But we're very glad that ice is less dense than water because it protects fish in the lakes. But usually, if you have a substance that's not water and freeze it, it is more dense than its liquid form. Liquids do not maintain a definite shape, but instead they take the shape of its container. So if I have a square cup that I pour something into, and then I pour it into a circular cup, that the liquid will take that shape, right? Liquids, however, do have a definite volume. If you measure the liquid in one container, you measure the liquid in another container, that volume will be the same. It also has a definite mass. So it's the same number of particles, regardless of the container. Same thing, you measure it in one cup, you measure it in a different cup, it should be the same, excluding the fact that some water might be left behind or evaporate over time. It still does have a definite mass. Those same particles are there, the same number of particles, so it does have the same amount of mass. Now, liquids tend to be less dense than solids, but are more dense than gases. So the gas form of a material will always be less dense than a liquid, but sometimes the liquid is more dense than solids, like with water, like we discussed on the last slide. But again, the majority of the time, if you have a substance in its liquid form, it is less dense than its solid form, and is definitely more dense than the gas form. Gases have no definite shape. They will take the form or the shape of their container, much like liquids, except they will fill the container while liquids will sit on the bottom and collect, They also have no definite volume. Gases take the volume of their container as well. So if I have a balloon full of helium, it's whatever that volume is. But if I pop this balloon, it's going to kind of leak out, spread, and become a different volume. However, gases do have a definite mass, okay? If I have 100 particles of that helium in that balloon, and I pop it, those 100 particles are just going to spread out and start moving around. They're not going to multiply. They're not going to do anything like that. Just like energy cannot be created or destroyed, matter cannot be created or destroyed. So there's not going to be just more helium atoms that come out of somewhere or nowhere. So it does actually have a definite mass. I know that's a little hard to wrap our head around because we can't see gases most of the time, but hopefully that makes some kind of sense. And gases tend to be the least dense. Now, there are some gases that are more dense than some liquids, believe it or not. There are some gases that are just extremely dense and basically act like a liquid. But they do tend to be the least dense. Okay, so how do you identify a state? So we know these three things these three properties about solids, liquids, and gases. So you kind of just need to go through the checklist. Does what you have maintain its shape? If it does, it's probably a solid because none of the other ones maintain their shape. Does it have a definite volume? Does it have a definite mass? Well, they all have a definite mass. But going through each of these and checking yes or no and then comparing to this list will help you identify if your substance is a solid, a liquid, or a gas. All right, that's all I have for you today. Have a wonderful day, everyone.